Hi, very good day to all. Today I'm going to show you how to perform the sensitivity analysis using Expert Plus. So the base case that we are going to use is exercise 2.4. So if you have the file generated based on exercise 2.4, you can start from there to add on your sensitivity analysis. So let's go to the simulation software. So here again I would like to emphasize the base case is actually the file that I have generated based on exercise 2.4, right? So we have the code stream. So this is the detail for the code stream, the Freon 12, and we have the hot stream, the ethylene glycol, and I have actually put the flow rate of 120 kilomole per hour for the ethylene glycol, right? So once you have put the stream specification, of course putting in the block specification or the specification for unit op is a shortcut method. And remember to put it as core current because it is a core current heat exchanger, and the rest of the spec is important, especially the exchanger specification. We have to specify the cold stream outlet temperature, which is 300 Kelvin. That is the purpose of having the heat exchanger, and the minimum temperature approach is 10 Kelvin. So with this, you run the simulation for exercise 2.4 and you get the status of results available. And based on the additional question given to you, you are asked to vary the flow rate from 95 to 120 kilomole per hour for the hot stream ethylene glycol. So you can either do it manually or you can utilize the sensitivity analysis tools under Expert Plus. Click Next and use the default name S1 for sensitivity analysis 1, and you'll be guided to the area for you to put in the details. So first is on the varying tab. Obviously you have to put in your varying parameters. Click New, and the column turn up for you to fill up the details. So the type of variable is this is a stream variable because it's the flow rate of hot stream. So which stream is it? It is hot in, the inlet for the hot stream, and it is more flow. Okay. So once you have chosen more flow, then the default unit is kilomole per hour. You would like to vary from 95 to 120 kilomole per hour with the interval of 5 kilomole per hour. So that is your varying parameter. Now you click Next, you'll be guided to the Define tab for you to set the parameter that you would like to observe. Of course, we would like to vary the EG flow rate because we would like to achieve the target of minimum temperature approach of 10 Kelvin. Okay. In order to achieve that, you have to make sure the outlet temperature for your hot stream is at least 310 Kelvin and above. So what we would like to observe is the outlet temperature for the hot stream. So we have to put it under the Define tab. So click New, and we put T out for hot stream. Okay. You can name it as you like, but make sure it is a clear definition, okay, or clear abbreviation to indicate it is the outlet temperature for the hot stream. So again, this is the stream variable, belongs to stream. Choose a stream variable. So which stream? So outlet temperature for the hot stream. So the stream is hot out, and temperature. So this is the parameter that we would like to observe. Okay, by manipulating the ethylene glycol flow rate. So once you have done the define tab, just click next. You'll be guided to tabulate tab. So as I mentioned earlier, you don't need to do anything, just click field variables, and this is done. Just again, next again, then you are asked to run the simulation because all the required input are there. Click OK. Now the results available with error. Why is it error? We have to analyze and sensitivity analysis. Okay, go to sensitivity and under the results button, click on it. You have a table showing you the varying parameter and the observed parameters. So the error of the simulation is because of the error for when you set the flow rate at 95 and 100 kmol per hour. This is your EQ flow rate. Error because you couldn't achieve the minimum temperature approach of 10 Kelvin due to the outlet temperature of the hot stream is only 308 and 309. Okay? So when the outlet temperature for the hot stream is more than 310 Kelvin, then you can get the results with OK status, meaning the results are available without error. Okay? So the minimum flow rate that you should use for ethylene glycol to achieve the minimum temperature approach of 10 Kelvin is at least 105 kmol per hour. So this is how you use the sensitivity analysis in X1 Plus to study the impact of certain important operating parameters to the performance of the heat exchanger. Right? So other than this, I think you are asked to study also the heat exchanger in counter current flow. So we are having the study for core current flow, right? So let's change it to counter current flow, see what will happen to our sensitivity analysis. So for counter current heat exchanger, you change the status to counter current and reset to push all the existing results, right? And then you run the simulation again and see what will happen. Okay, now the results are available without error. Let's check our sensitivity analysis. Okay, we go to sensitivity analysis under results. Okay, it seems like 95 kmol per hour of EG also can let us achieve the minimum temperature approach of 10 Kelvin, because the outlet temperature for the hot stream is supposed to be at least 250 Kelvin only. If you refer back to the temperature profile in my slide, if you are having a counter current flow heat exchanger, the temperature or the outlet temperature for the hot stream only at least 250 Kelvin and above. Okay? That's why you need a lesser flow rate to achieve that. Okay? Let's change the range for the manipulated variable and determine the minimum flow rate that we should use to achieve the minimum temperature of 10 Kelvin in counter current flow heat exchanger. So we change it to maybe 10 kmol per hour. Okay, we reset everything, push all the existing result and run the simulation again. Right? So now the results are available with error. So let's check the sensitivity analysis results. So these are the table that we have. So it seems like when the flow rate is from 10 to 40, the results are available with error because we can't achieve the minimum temperature approach of 10 Kelvin with the outlet temperature for the hot stream of at least more than 250 Kelvin. Okay? So when the flow rate of EG is more than 45 or at 45, then we can achieve the minimum temperature approach of 10 Kelvin with the outlet temperature for the hot stream of 257 Kelvin, right? So as simple it is, if you know how to use the sensitivity analysis tools in X1 Plus. At least you don't need to do it manually and occupy a lot of your time. You just need to know how to use the sensitivity analysis tools, and this is the beauty of the computer aided design. Speed up the design or speed up the analysis using a computer tools. So with this, I hope you can at least learn how to use sensitivity analysis and practice it. What you need to be clear is what is the manipulated variable, what are the variables that you would like to observe. So you have to clear on these two variables, then you are able to perform the sensitivity analysis. With this, I would like to thank for your attention. Thank you very much.